Picture this, a swirling cosmic masterpiece, 25 million light-years away, where stars are born and mysteries unfold in every corner. This is the Pinwheel Galaxy, a celestial wonder that defies our understanding of the universe. What makes this galaxy so extraordinary? It's not just its breathtaking spiral arms or its vibrant starburst regions. It's the 25 strange phenomena hidden within its depths, each one a puzzle waiting to be solved. From supermassive black holes to unexplained radio signals, the Pinwheel Galaxy holds secrets that challenge even the brightest minds in astronomy. Why does this galaxy glow with such intensity? What forces shape its unusual structure? And what can its mysteries teach us about the cosmos? Stay with us as we dive into the heart of this galactic enigma, uncovering the 25 phenomena that make the Pinwheel Galaxy one of the most fascinating places in the universe. By the end of this journey, you'll see the night sky in a whole new light. Ready to explore? Let's begin. Now, let's turn our attention to the very heart of the Pinwheel Galaxy, where a colossal force lies hidden, a supermassive black hole. This isn't just any black hole, it's a gravitational giant millions of times more massive than our Sun, anchoring the galaxy with its immense pull. But what makes this black hole so intriguing? For starters, its sheer size is staggering. Imagine a cosmic vacuum so powerful that not even light can escape its grasp. This black hole doesn't just sit quietly at the center, it actively shapes the galaxy around it. Its gravitational influence dictates the motion of stars, gas, and dust, orchestrating the galaxy's spiral dance. Scientists believe this supermassive black hole formed billions of years ago, possibly from the collapse of a massive gas cloud or the merging of smaller black holes. Over time, it grew by devouring nearby matter, growing into the behemoth we observe today. But its role goes beyond just consuming. This black hole is a key player in galactic evolution. Its energy output, in the form of jets and radiation, can trigger star formation in some regions while halting it in others. It's like a cosmic conductor, balancing creation and destruction on a galactic scale. Yet, mysteries remain. How exactly did it grow so massive? What happens to the matter it consumes? And how does its activity influence the galaxy's future? These questions keep astronomers on the edge of their seats, studying this enigmatic force at the center of the Pinwheel Galaxy. As we continue our journey, we'll uncover even more of the galaxy's secrets, but for now, let's marvel at the supermassive black hole, a silent, invisible ruler shaping the cosmos in ways we're only beginning to understand. Now, shifting our gaze from the galaxy's mysterious core, let's take a closer look at one of the Pinwheel Galaxy's most striking features, its spiral arms. These arms aren't just beautiful, they're also unusually bright and well-defined, setting them apart from the spiral arms of many other galaxies. But what makes them so unique? For starters, their brightness comes from an abundance of young, hot stars and active star-forming regions. These areas are teeming with life, glowing with the energy of countless newborn stars. Unlike the more diffuse or fragmented arms seen in some galaxies, the Pinwheel Galaxy's spiral arms are remarkably sharp and continuous. This clarity suggests a highly organized structure, likely influenced by the galaxy's rotation and the gravitational forces at play. The arms act like cosmic conveyor belts, channeling gas and dust into dense regions where stars are born. This process, known as density wave theory, explains how the arms maintain their shape over time, even as stars and gas move through them. But there's more to these arms than meets the eye. Their brightness also hints at a high rate of star formation, making the Pinwheel Galaxy a hotspot for stellar activity. This intense star birth isn't random. It's driven by the compression of gas and dust as they spiral inward, creating the perfect conditions for new stars to ignite. These spiral arms are essentially cosmic nurseries, where the galaxy's future is being written in the light of young stars. What's truly fascinating is how these arms reveal the galaxy's history and dynamics. By studying their structure and composition, astronomers can piece together the story of how the Pinwheel Galaxy evolved over billions of years. The arms also provide clues about the distribution of dark matter and the forces shaping the galaxy's rotation. As we continue our journey through the Pinwheel Galaxy, these spiral arms serve as a reminder of the delicate balance between chaos and order in the cosmos. They're not just beautiful features, they're windows into the processes that shape galaxies and the universe itself. Next, we'll dive into another extraordinary phenomenon, the starburst regions that light up this galaxy like cosmic fireworks. Now, let's turn our attention to one of the most dazzling features of the Pinwheel Galaxy, its starburst regions. These areas are like cosmic fireworks, bursting with the birth of new stars at an astonishing rate. But what exactly makes these regions so active, and why do they shine so brightly? Starburst regions are pockets of the galaxy where star formation happens at an extraordinary pace, far exceeding the rate seen in most other galaxies. In the Pinwheel Galaxy, these regions are scattered throughout its spiral arms, glowing with the light of countless young, massive stars. These stars are born from the dense clouds of gas and dust that fill these areas, compressed by the galaxy's rotation and gravitational forces. What sets these regions apart is their intensity. The sheer amount of gas and dust available in the Pinwheel Galaxy creates the perfect conditions for rapid star formation. As these materials collapse under their own gravity, they ignite into new stars, some of which are dozens of times more massive than our Sun. These massive stars burn brightly but live short lives, often ending in spectacular supernovae that scatter heavy elements back into the galaxy, fueling future generations of stars. The starburst regions don't just light up the galaxy, they also play a crucial role in shaping its overall structure and evolution. The energy released by these young stars heats the surrounding gas, creating bubbles and shockwaves that ripple through the galaxy. These processes can trigger even more star formation, creating a feedback loop that keeps the galaxy vibrant and dynamic. But why is the Pinwheel Galaxy so rich in starburst activity? One theory points to its interactions with neighboring galaxies. Gravitational tugs from nearby cosmic companions may have stirred up the galaxy's gas, compressing it into dense regions where stars can form. Another possibility is that the galaxy's spiral arms act as natural catalysts, funneling gas and dust into these hotspots of stellar activity. The luminosity of these starburst regions is a key reason why the Pinwheel Galaxy shines so brightly in the night sky. They contribute significantly to the galaxy's overall light output, making it one of the most visually stunning objects in the universe. But beyond their beauty, these regions offer astronomers a glimpse into the processes that drive galactic evolution. As we move forward, we'll explore another intriguing aspect of the Pinwheel Galaxy, the mysterious dark matter halo that surrounds it, holding its stars and gas together in an invisible embrace. Now, let's shift our focus to something invisible yet incredibly powerful, the mysterious dark matter halo surrounding the Pinwheel Galaxy. While we can't see it directly, this halo plays a vital role in shaping the galaxy's structure and behavior. But what exactly is dark matter, and how does it hold the galaxy together? Dark matter is a mysterious substance that doesn't emit, absorb, or reflect light, making it completely invisible to our telescopes. Despite this, we know it exists because of its gravitational effects on visible matter, like stars and gas. In the case of the Pinwheel Galaxy, the dark matter halo acts like an invisible scaffold, providing the gravitational glue that keeps the galaxy's stars, gas, and dust from flying apart. Without it, the galaxy would simply unravel. So, how do scientists study something they can't see? They rely on indirect methods, such as observing the motion of stars and gas within the galaxy. By measuring how fast these objects move, astronomers can infer the presence and distribution of dark matter. For example, stars on the outer edges of the Pinwheel Galaxy move faster than they should if only visible matter were present. This discrepancy points to the gravitational influence of dark matter, which extends far beyond the galaxy's visible boundaries. The dark matter halo also helps explain why the Pinwheel Galaxy maintains its spiral shape. The gravitational pull of the halo keeps the galaxy's spiral arms tightly wound, preventing them from dispersing over time. Additionally, dark matter plays a key role in the formation of galaxies themselves. In the early universe, dark matter clumped together, creating gravitational wells that attracted gas and dust, eventually leading to the birth of galaxies like the Pinwheel. But the mystery of dark matter doesn't end there. Scientists are still trying to figure out what it's made of. Some theories suggest it could be composed of exotic particles that interact weakly with ordinary matter, while others propose entirely new physics to explain its nature. Despite decades of research, dark matter remains one of the greatest unsolved puzzles in modern astronomy. As we continue our journey through the Pinwheel Galaxy, we'll uncover another fascinating phenomenon: the giant molecular clouds that serve as the birthplaces of stars, where the next chapter of cosmic creation unfolds. Now, let's turn our attention to the colossal nurseries of the cosmos, the giant molecular clouds scattered throughout the Pinwheel Galaxy. These vast, dense regions of gas and dust are where stars are born, making them some of the most dynamic and fascinating features in the galaxy. But what exactly are these clouds, and how do they give rise to the brilliant stars that light up the night sky? Giant molecular clouds are enormous structures, often spanning hundreds of light years across and containing enough material to form thousands, even millions of stars. They're primarily composed of molecular hydrogen, the simplest and most abundant molecule in the universe, along with traces of other gases like carbon monoxide and dust particles. These clouds are incredibly cold, with temperatures hovering just a few degrees above absolute zero, which allows gravity to take hold and begin the process of star formation. The birth of a star begins when a small region within the cloud becomes denser than its surroundings, often triggered by external forces like shock waves from nearby supernova or the gravitational pull of passing stars. As this dense region collapses under its own gravity, it fragments into smaller clumps, each of which can eventually form a star. Over time, these clumps heat up and ignite nuclear fusion, transforming into the glowing orbs we recognize as stars. But the role of giant molecular clouds doesn't end with star birth. They also play a crucial part in shaping the galaxy's structure and evolution. As stars form within these clouds, they release energy and radiation, which can push away surrounding gas and dust, creating bubbles and cavities. This process not only influences the formation of new stars, but also enriches the galaxy with heavier elements forged in stellar cores, paving the way for the creation of planets and, potentially, life. Interestingly, the Pinwheel Galaxy's giant molecular clouds are particularly active, contributing to its reputation as a star-forming powerhouse. Observations reveal that these clouds are more abundant and more massive than those found in many other galaxies, which may explain why the Pinwheel Galaxy shines so brightly in the night sky. As we move forward, we'll explore another extraordinary phenomenon: the hypervelocity stars that race through the galaxy at incredible speeds, defying the gravitational pull that binds most celestial objects. These cosmic speedsters hold clues to some of the most dramatic events in the Pinwheel Galaxy's history. Now, shifting our gaze to the stars that defy the very fabric of cosmic order, we encounter the hypervelocity stars of the Pinwheel Galaxy. These celestial speedsters are unlike any ordinary stars, racing through the galaxy at astonishing speeds that can exceed hundreds of kilometers per second. But how do these stars achieve such incredible velocities, and what can their trajectories reveal about the forces at play within the galaxy? Hypervelocity stars are born from some of the most dramatic events in the universe. One of the primary mechanisms behind their incredible speed is the interaction with the supermassive black hole at the galaxy's center. When a binary star system, a pair of stars orbiting each other, ventures too close to the black hole, the immense gravitational forces can tear the system apart. One star is captured by the black hole, while the other is flung outward at an extraordinary speed, becoming a hypervelocity star. This cosmic slingshot effect propels the star to velocities so high that it can escape the galaxy's gravitational pull entirely. But the story doesn't end there. Hypervelocity stars can also be created through other violent processes, such as supernova explosions. When a massive star explodes, the force of the blast can eject its companion star at incredible speeds, sending it hurtling through space. These stars, too, become hypervelocity travelers, leaving behind their origins to journey across the galaxy, or even beyond it. The trajectories of these stars are like cosmic breadcrumbs, offering clues about the gravitational forces shaping the Pinwheel Galaxy. By studying their paths, astronomers can map the distribution of dark matter and better understand the galaxy's overall structure. Hypervelocity stars also provide insights into the dynamics of the galactic center, where the supermassive black hole resides, and the extreme environments that give rise to such phenomena. What makes the Pinwheel Galaxy particularly intriguing is the sheer number of hypervelocity stars observed within it. This abundance suggests that the galaxy's central black hole is exceptionally active, frequently disrupting star systems and launching these stellar speedsters into the void. Each hypervelocity star is a testament to the galaxy's turbulent history and the powerful forces that continue to shape its evolution. As we continue our journey through the Pinwheel Galaxy's mysteries, we'll next explore the rare but awe-inspiring gamma-ray bursts that light up the cosmos with unimaginable energy. These fleeting yet powerful events hold secrets to some of the most extreme processes in the universe. Now, let's turn our attention to one of the most explosive and fleeting events in the cosmos: gamma-ray bursts. These bursts are like cosmic fireworks, releasing more energy in a few seconds than our Sun will emit in its entire lifetime. Originating from the Pinwheel Galaxy, these bursts are rare but incredibly powerful, offering a glimpse into some of the most extreme processes in the universe. Gamma-ray bursts are typically caused by two main events. The first occurs when a massive star, many times larger than our Sun, reaches the end of its life and collapses under its own gravity. This collapse triggers a supernova explosion, but in some cases, the core of the star doesn't just form a neutron star or black hole. It also produces a jet of energy that shoots out at nearly the speed of light. This jet, packed with gamma rays, is what we detect as a gamma-ray burst. These bursts are so intense that they can outshine entire galaxies for a brief moment. The second cause of gamma-ray bursts involves the collision of two neutron stars. Neutron stars are the incredibly dense remnants of supernova explosions, and when two of them spiral into each other, the resulting collision releases an enormous amount of energy in the form of gamma rays. This event not only produces a gamma-ray burst but also sends ripples through space-time, known as gravitational waves, which scientists can detect here on Earth. The impact of these bursts on the surrounding space is profound. The intense radiation can ionize gas in nearby regions, stripping electrons from atoms and altering the chemical composition of interstellar material. This process can influence star formation and even affect the evolution of galaxies over time. In the Pinwheel Galaxy, gamma-ray bursts are a reminder of the violent and dynamic processes that shape the universe. What makes these bursts particularly fascinating is their unpredictability. They appear without warning and vanish just as quickly, leaving astronomers scrambling to study them before they fade. Yet, each burst provides valuable data, helping scientists understand the life cycles of stars, the behavior of neutron stars, and the nature of extreme cosmic events. As we move forward, we'll delve into another enigmatic feature of the Pinwheel Galaxy, the peculiar neutron stars that defy our expectations with their unusual magnetic fields and rapid spins. These stellar remnants hold secrets that could reshape our understanding of the universe's most extreme environments. Now, let's shift our gaze to another cosmic marvel within the Pinwheel Galaxy, the peculiar neutron stars. These stellar remnants are the dense cores left behind after a massive star explodes in a supernova. Imagine squeezing the mass of our Sun into a sphere no larger than a city. That's the incredible density of a neutron star, where a single teaspoon of its material would weigh billions of tons on Earth. But what makes these neutron stars in the Pinwheel Galaxy truly stand out are their bizarre and extreme properties. Some neutron stars here spin at mind-boggling speeds, completing hundreds of rotations every second. These rapidly spinning stars, known as pulsars, emit beams of radiation that sweep across space like cosmic lighthouses. When these beams point toward Earth, we detect them as regular pulses of light or radio waves. But not all neutron stars are content with just spinning fast. Some possess magnetic fields so intense that they defy comprehension. These are the magnetars, neutron stars with magnetic fields trillions of times stronger than Earth. To put that into perspective, a magnetar's magnetic field could erase the data on every credit card on Earth from halfway across the galaxy. The formation of these neutron stars is as dramatic as their behavior. When a massive star exhausts its nuclear fuel, its core collapses under its own gravity. This collapse triggers a supernova explosion, blasting the star's outer layers into space while leaving behind a dense, spinning core, the neutron star. But not all neutron stars are created equal. The ones with extreme magnetic fields or rapid spins often form under unique conditions, such as the collision of two neutron stars or the merger of a neutron star with a black hole. These events can amplify their magnetic fields or spin rates to extraordinary levels. What makes these neutron stars so fascinating to astronomers is their ability to push the boundaries of physics. They exist in environments where gravity is so strong that it warps space-time, and matter behaves in ways we can't replicate on Earth. Studying these stars helps scientists test theories about the nature of matter, the behavior of magnetic fields in extreme conditions, and even the limits of Einstein's theory of general relativity. In the Pinwheel Galaxy, these peculiar neutron stars serve as natural laboratories, offering insights into some of the most extreme and mysterious processes in the universe. As we continue our journey through the Pinwheel Galaxy, we'll next explore another cosmic mystery, the unexplained radio emissions that have puzzled scientists for decades. These signals, originating from deep within the galaxy, could hold clues to some of the universe's most profound secrets. Now, let's turn our attention to one of the most intriguing mysteries of the Pinwheel Galaxy, the unexplained radio emissions that have left scientists scratching their heads. These strange signals detected from deep within the galaxy are unlike anything we've observed before. They come in bursts, sometimes lasting just milliseconds, and their origins remain shrouded in mystery. What could be producing these enigmatic radio waves, and why do they seem to defy our current understanding of the cosmos? One leading theory points to black holes as the potential source. When matter spirals into a black hole, it can release intense bursts of energy, including radio waves. In the Pinwheel Galaxy, supermassive black holes or even smaller stellar mass black holes could be responsible for these emissions. However, the patterns and frequencies of these signals don't always match what we'd expect from black hole activity, leaving room for other possibilities. Another fascinating idea is that these radio emissions could be linked to neutron stars, particularly those with extreme magnetic fields, like the magnetars we discussed earlier. These highly magnetized stars can produce powerful bursts of radio waves, especially during starquakes, sudden shifts in their crusts. Yet, even this explanation doesn't fully account for all the peculiar characteristics of the signals detected in the Pinwheel Galaxy. Then, of course, there's the more speculative possibility. Could these radio emissions be evidence of extraterrestrial intelligence? While it's a tantalizing thought, scientists approach this idea with caution. The search for extraterrestrial signals, known as SETI, has long sought to identify patterns that might indicate intelligent life. However, the radio emissions from the Pinwheel Galaxy don't yet fit the criteria for artificial origins. They're more likely to be natural phenomena, albeit ones we don't fully understand. What makes these radio emissions so puzzling is their unpredictability. They don't follow a regular pattern, making them difficult to study and even harder to pinpoint. Some scientists believe they could be the result of rare cosmic events, such as the collision of neutron stars or the explosive deaths of massive stars. Others suggest they might be linked to dark matter or other exotic phenomena that we've yet to discover. The mystery of these radio emissions highlights just how much we still have to learn about the universe. Each signal we detect offers a clue, but piecing together the full picture requires patience, advanced technology, and a willingness to explore the unknown. As we continue to study the Pinwheel Galaxy, these unexplained radio waves remind us that the cosmos is full of surprises waiting to be uncovered. Next, we'll delve into another fascinating aspect of the Pinwheel Galaxy, evidence of galactic cannibalism. This phenomenon reveals how the galaxy has grown over time, absorbing smaller galaxies and reshaping its structure in the process. Now, let's explore a phenomenon that reveals the Pinwheel Galaxy's dramatic past, evidence of galactic cannibalism. This process, where larger galaxies consume smaller ones, is a cosmic dance that has shaped the Pinwheel Galaxy into the stunning spiral we see today. But how do we know this has happened, and what does it mean for the galaxy's structure and composition? One of the key pieces of evidence lies in the distribution of stars within the Pinwheel Galaxy. Astronomers have observed streams of stars that don't quite fit with the galaxy's overall rotation. These stellar streams are often the remnants of smaller galaxies that were torn apart by the Pinwheel Galaxy's immense gravitational pull. As these smaller galaxies were absorbed, their stars were scattered, creating these telltale trails that we can still detect today. Another clue comes from the galaxy's globular clusters, dense groups of ancient stars that orbit the galaxy's core. In the Pinwheel Galaxy, some of these clusters have unusual chemical compositions, suggesting they originated from outside the galaxy. This is a strong indication that they were once part of smaller galaxies that were consumed during the Pinwheel Galaxy's growth. Galactic cannibalism isn't just about stars, it also affects the galaxy's gas and dust. When a smaller galaxy is absorbed, its gas is often funneled into the larger galaxy's core, fueling intense bursts of star formation. This process can explain why the Pinwheel Galaxy has such vibrant starburst regions, where new stars are born at an astonishing rate. The influx of fresh material from these smaller galaxies has likely played a crucial role in shaping the galaxy's spiral arms and overall structure. But what does this mean for the Pinwheel Galaxy's future? As it continues to grow by consuming smaller neighbors, its structure will evolve. The added mass from these mergers can alter the galaxy's gravitational field, potentially leading to changes in its spiral arms or even triggering new waves of star formation. Over billions of years, this process of galactic cannibalism will continue to shape the Pinwheel Galaxy, leaving behind a legacy of cosmic collisions and transformations. This phenomenon reminds us that galaxies are not static. They are dynamic, ever-changing entities shaped by their interactions with the universe around them. The Pinwheel Galaxy's history of galactic cannibalism offers a glimpse into the violent yet beautiful processes that drive the evolution of the cosmos. Next, we'll turn our attention to another intriguing feature of the Pinwheel Galaxy, the unusual distribution of its globular clusters. These ancient star clusters hold secrets about the galaxy's formation and its journey through the universe. Now, let's shift our focus to one of the most puzzling features of the Pinwheel Galaxy, the unusual distribution of its globular clusters. These dense, ancient star clusters which orbit the galaxy's core are not spread out in the way we typically see in other galaxies. Instead, they form a unique pattern that has left astronomers scratching their heads. What could this strange arrangement tell us about the Pinwheel Galaxy's past? Globular clusters are like cosmic time capsules containing some of the oldest stars in the universe. In most galaxies, these clusters are evenly distributed around the galactic center, forming a kind of spherical halo. But in the Pinwheel Galaxy, they're arranged in a more irregular, lopsided pattern. Some clusters are found much farther from the core than usual, while others are grouped together in unexpected ways. This unusual distribution suggests that something dramatic has happened in the galaxy's history, something that disrupted the typical arrangement of these star clusters. One possible explanation lies in the Pinwheel Galaxy's history of galactic cannibalism, which we explored earlier. As the galaxy absorbed smaller neighbors, the gravitational forces involved could have flung some of its globular clusters into unusual orbits. The influx of new material from these mergers might have also triggered the formation of new clusters in unexpected locations. This chaotic process could explain why the Pinwheel Galaxy's globular clusters are scattered so differently compared to those in other galaxies. Another clue comes from the chemical makeup of these clusters. Some of them have distinct compositions that don't match the rest of the galaxy's stars, hinting that they might have originated from outside the Pinwheel Galaxy. This supports the idea that these clusters were once part of smaller galaxies that were consumed, bringing their own globular clusters along for the ride. Over time, these clusters were integrated into the Pinwheel Galaxy, but their unique origins left a lasting mark on their distribution. The unusual arrangement of globular clusters also provides insights into the galaxy's overall structure and evolution. For example, the presence of clusters at greater distances from the core suggests that the Pinwheel Galaxy's gravitational influence extends farther than we might expect. This could mean that the galaxy is more massive than it appears, with a significant amount of dark matter helping to hold these distant clusters in place. By studying these ancient star clusters, astronomers can piece together a timeline of the Pinwheel Galaxy's growth and transformation. Each cluster is like a chapter in the galaxy's history, revealing clues about the cosmic events that shaped it over billions of years. The strange distribution of these clusters is a testament to the dynamic, ever-changing nature of galaxies, and a reminder that even the oldest structures in the universe still have stories to tell. Next, we'll delve into another fascinating aspect of the Pinwheel Galaxy, its unusually high rate of supernova. These explosive events not only light up the galaxy, but also play a crucial role in shaping its future. Now, let's turn our attention to one of the most explosive phenomena in the Pinwheel Galaxy, its unusually high rate of supernova. These colossal stellar explosions are not just spectacular cosmic fireworks. They play a vital role in shaping the galaxy's future. The Pinwheel Galaxy experiences supernova at a rate that far exceeds what we see in many other galaxies, and this has profound implications for its structure and evolution. Supernova occur when massive stars reach the end of their lives, collapsing under their own gravity and exploding with unimaginable energy. In the Pinwheel Galaxy, these events happen more frequently than expected, lighting up the galaxy with bursts of light and radiation. This high rate of supernova suggests that the galaxy is home to an unusually large number of massive stars, which burn brightly and die young. These stars are the engines of star formation, and their explosive deaths create the raw materials needed for new stars and planets to form. When a supernova explodes, it scatters heavy elements like iron, gold, and uranium into space. These elements, forged in the hearts of dying stars, are essential building blocks for future generations of stars and planets. In the Pinwheel Galaxy, the frequent supernova mean that these elements are being spread throughout the galaxy at a rapid pace. This enriches the galaxy's interstellar medium, the vast clouds of gas and dust between stars, and sets the stage for ongoing star formation. Over time, this process shapes the galaxy's chemical composition, making it a fertile ground for new stellar systems. The high rate of supernova also has a dramatic impact on the galaxy's structure. The energy released by these explosions can trigger shock waves that compress nearby gas clouds, sparking the birth of new stars. This creates a feedback loop where supernova not only end the lives of stars but also give rise to new ones. In the Pinwheel Galaxy, this cycle is happening on a grand scale, contributing to its vibrant and dynamic appearance, but the story doesn't end there. Supernova also play a key role in regulating star formation across the galaxy. The intense radiation and shock waves from these explosions can heat up and disperse gas clouds, preventing them from collapsing to form new stars. This delicate balance between creation and destruction helps maintain the galaxy's overall structure and ensures that star formation doesn't run out of control. By studying the Pinwheel Galaxy supernova, astronomers gain valuable insights into the life cycles of stars and the processes that drive galactic evolution. Each explosion is a reminder of the interconnectedness of the cosmos, where the death of one star can lead to the birth of countless others. The high rate of supernova in the Pinwheel Galaxy is a testament to its active and ever-changing nature, offering a glimpse into the forces that shape the universe. Next, we'll explore another intriguing feature of the Pinwheel Galaxy, the mysterious dark nebulae that obscure parts of its dazzling light. These shadowy regions hold secrets of their own, and they play a crucial role in the galaxy's story. Now, let's shift our gaze to the shadowy regions of the Pinwheel Galaxy, the mysterious dark nebulae. These enigmatic clouds of gas and dust are more than just cosmic curtains blocking the galaxy's light. They are vital pieces of the puzzle in understanding how galaxies like the Pinwheel evolve and function. Dark nebulae are dense clouds of interstellar material, primarily composed of gas and tiny dust particles. These particles are so thick that they absorb and scatter the light from stars behind them, creating what appear to be dark patches against the galaxy's glowing backdrop. But don't let their appearance fool you. These nebulae are far from empty. In fact, they are some of the most fertile regions in the galaxy, serving as the birthplaces of new stars. The formation of dark nebulae begins with the cooling and clumping of gas in the interstellar medium. Over time, gravity pulls these clumps together, causing them to grow denser and denser. As the material accumulates, it blocks the light from stars and other luminous objects behind it, giving the nebula its characteristic dark appearance. Within these dense clouds, temperatures can drop to just a few degrees above absolute zero, creating the perfect conditions for molecules to form and for star formation to begin. But what makes dark nebulae so important? For one, they act as cosmic nurseries where the seeds of future stars are sown. The dust and gas within these nebulae provide the raw materials needed for star formation. As gravity continues to pull the material together, it forms dense cores that eventually collapse under their own weight, igniting the nuclear fusion that powers stars. In the Pinwheel Galaxy, these dark nebulae are scattered throughout its spiral arms, contributing to the galaxy's ongoing cycle of star birth and death. Dark nebulae also play a crucial role in shaping the galaxy's structure. By absorbing and scattering light, they help regulate the flow of energy within the galaxy. This process can influence the temperature and density of the interstellar medium, which in turn affects where and how new stars form. Additionally, the dust within these nebulae is rich in complex molecules, including organic compounds that are essential for the formation of planets and potentially life. Studying dark nebulae in the Pinwheel Galaxy gives astronomers a unique window into the early stages of star formation. By observing how these clouds evolve and interact with their surroundings, scientists can better understand the processes that drive galactic evolution. These shadowy regions may seem mysterious, but they are key to unraveling the story of how galaxies like the Pinwheel come to be. As we continue our journey through the Pinwheel Galaxy, we'll next uncover the strange alignment of magnetic fields that shapes its cosmic landscape. These invisible forces hold secrets of their own, influencing everything from star formation to the movement of cosmic particles. Now, let's turn our attention to another fascinating feature of the Pinwheel Galaxy, the strange alignment of its magnetic fields. These invisible forces, though unseen, play a crucial role in shaping the galaxy's structure and behavior, influencing everything from the birth of stars to the movement of cosmic particles. Magnetic fields in galaxies are like invisible threads woven through space, guiding and shaping the flow of matter and energy. In the Pinwheel Galaxy, these fields are unusually aligned, creating patterns that are both intriguing and puzzling to astronomers. Unlike the more chaotic magnetic fields found in some other galaxies, the Pinwheel's fields appear to follow a more organized structure, often aligning with the galaxy's spiral arms. This alignment is not just a cosmic coincidence, it has profound implications for how the galaxy evolves. One of the most significant effects of these aligned magnetic fields is their impact on star formation. Magnetic fields can influence the way gas and dust clump together in the interstellar medium. In the Pinwheel Galaxy, the organized fields help channel material into the spiral arms where it can accumulate and form dense clouds. These clouds, as we've seen earlier, are the birthplaces of new stars. By guiding the flow of gas and dust, the magnetic fields essentially act as cosmic architects, shaping the regions where stars are born. But the influence of these fields doesn't stop there. They also play a role in regulating the movement of cosmic particles, such as charged particles and cosmic rays. Magnetic fields can accelerate these particles to incredible speeds, creating high-energy phenomena that light up the galaxy. In the Pinwheel Galaxy, the aligned fields may be responsible for the unusual distribution of cosmic rays, which are often concentrated along the spiral arms. This concentration can lead to the formation of bright, energetic regions that stand out against the galaxy's backdrop. The alignment of magnetic fields also affects the overall dynamics of the galaxy. By influencing the motion of gas and particles, these fields can help maintain the galaxy's spiral structure. They act as a stabilizing force, preventing the galaxy from becoming too chaotic or losing its distinctive shape. This balance between order and chaos is one of the reasons the Pinwheel Galaxy remains such a captivating subject of study. So, how do astronomers study these invisible forces? One method is by observing the polarization of light emitted by stars and other celestial objects. As light passes through magnetic fields, its orientation can change, revealing the direction and strength of the fields. By mapping these changes, scientists can piece together a picture of the galaxy's magnetic landscape. In the Pinwheel Galaxy, these observations have revealed a magnetic structure that is both complex and beautifully aligned with its spiral arms. As we continue to explore the Pinwheel Galaxy, we'll next uncover the enigmatic blue straggler stars that seem to defy the rules of stellar aging. These cosmic anomalies hold secrets of their own, offering clues about the galaxy's history and the processes that shape its stellar population. Now, shifting our gaze to another cosmic puzzle, we encounter the enigmatic blue straggler stars. These stars stand out in the Pinwheel Galaxy because they seem to defy the natural aging process of stars. While most stars in a galaxy follow a predictable life cycle, blue stragglers appear younger, hotter, and more luminous than their neighboring stars. This peculiar behavior has made them a subject of fascination and intense study among astronomers. So, what makes these stars so unusual? Blue stragglers are typically found in older star clusters, where most stars are cooler and redder due to their advanced age. Yet, these stragglers shine with a bright blue hue, indicating they are much hotter and more energetic. This contradiction has led scientists to propose several theories about their origins. One leading idea is that blue stragglers are the result of stellar collisions. When two stars collide, their combined mass and energy can create a new, more massive star that burns hotter and brighter than its surroundings. This process essentially resets the star's clock, making it appear younger than it truly is. Another compelling theory involves binary star systems. In some cases, two stars orbiting each other closely can interact in ways that lead to a merger. As one star transfers material to its companion, the receiving star gains mass and energy, rejuvenating it into a blue straggler. This process not only explains their youthful appearance, but also provides insight into the dynamic interactions within binary systems. The presence of blue stragglers in the Pinwheel Galaxy offers a unique window into the galaxy's history. By studying these stars, astronomers can piece together clues about past stellar interactions and the conditions that led to their formation. For instance, the density of stars in certain regions of the galaxy might increase the likelihood of collisions or mergers, creating more blue stragglers. This, in turn, helps scientists understand how the galaxy's environment influences the evolution of its stellar population. But the mystery doesn't end there. Blue stragglers also challenge our understanding of stellar evolution. Their existence suggests that stars can undergo dramatic transformations, defying the standard models of aging. This has prompted astronomers to refine their theories and explore new possibilities, such as the role of magnetic fields or the influence of dark matter in shaping these stars. As we continue to unravel the secrets of the Pinwheel Galaxy, the blue stragglers remind us that the cosmos is full of surprises. These stars, with their seemingly eternal youth, invite us to question what we know about the life cycles of stars and the forces that govern them. Next, we'll delve into the unexplained X-ray sources scattered throughout the galaxy, another intriguing phenomenon that adds to the pinwheel's cosmic allure. Now, turning our attention to another cosmic enigma, we encounter the unexplained X-ray sources scattered throughout the Pinwheel Galaxy. These mysterious emissions of high-energy X-rays have puzzled astronomers for decades, as their origins remain shrouded in uncertainty. Unlike the steady glow of stars or the predictable bursts of supernova, these X-ray sources flicker and flare in ways that defy easy explanation. What could be producing such intense and erratic energy? One leading theory points to black holes as the culprits. When matter falls into a black hole, it heats up to extreme temperatures, emitting X-rays as it spirals inward. In the Pinwheel Galaxy, there could be numerous stellar mass black holes formed from the collapse of massive stars that are actively consuming nearby material. These black holes, though invisible themselves, reveal their presence through the X-rays they emit. However, not all X-ray sources fit neatly into this explanation, leaving room for other possibilities. Another strong contender is neutron stars. These incredibly dense remnants of supernova explosions can also produce powerful X-rays, especially if they are part of a binary system. As a neutron star pulls material from its companion star, the infalling matter accelerates and heats up, releasing bursts of X-ray energy. Some neutron stars, known as pulsars, emit regular pulses of X-rays as they rotate, creating a detectable signal. Yet, many of the X-ray sources in the Pinwheel Galaxy don't match the expected patterns of neutron stars, adding to the mystery. Adding to the intrigue, some X-ray sources appear to be isolated, with no visible companion stars or other objects nearby. This has led scientists to consider more exotic explanations, such as intermediate mass black holes or even the remnants of ancient stellar collisions. Intermediate mass black holes, which are larger than stellar mass black holes but smaller than supermassive ones, could explain some of the more intense and isolated X-ray emissions. However, their existence is still a topic of debate, making this theory both tantalizing and speculative. The study of these X-ray sources is further complicated by their variability. Some flare up suddenly and then fade away, while others flicker unpredictably over time. This erratic behavior makes it challenging to pinpoint their exact nature, as traditional models of black holes and neutron stars often fail to account for such irregular activity. Could there be entirely new types of cosmic objects at play, or are we simply missing a piece of the puzzle in our current understanding of astrophysics? The unexplained X-ray sources in the Pinwheel Galaxy serve as a reminder of how much we still have to learn about the universe. They challenge our existing theories and push astronomers to develop new tools and techniques to study these elusive phenomena. By unraveling their secrets, we not only gain insight into the Pinwheel Galaxy, but also deepen our understanding of the fundamental processes that shape the cosmos. Next, we'll explore the powerful galactic winds that flow through the galaxy, shaping its evolution in ways that are both dramatic and mysterious. Now, shifting our gaze to another awe-inspiring feature of the Pinwheel Galaxy, we encounter the phenomenon of galactic winds. These are not the gentle breezes we experience on Earth, but rather colossal streams of gas and particles that flow outward from the galaxy at incredible speeds. These winds are so powerful that they can shape the very structure and future of the galaxy itself. Galactic winds are generated by a combination of intense star formation and the activity of supermassive black holes. In regions where stars are born at a rapid pace, the energy from young, massive stars heats the surrounding gas, causing it to expand and escape the galaxy's gravitational pull. Supernova, the explosive deaths of these massive stars, further contribute to this process by blasting material outward at high velocities. Meanwhile, the supermassive black hole at the galaxy's center can also play a role. As it consumes matter, it releases enormous amounts of energy, driving jets and winds that push gas and particles into intergalactic space. The impact of these winds is profound. They carry away vast amounts of gas, which is the raw material needed for forming new stars. Over time, this can slow down or even halt star formation in certain regions of the galaxy. However, these winds also have a constructive side. By redistributing gas and heavy elements, they enrich the surrounding intergalactic medium, potentially seeding future star formation in other galaxies or regions. This process is crucial for understanding how galaxies evolve and interact with their cosmic environment. One of the most fascinating aspects of galactic winds is their ability to create feedback loops. As they remove gas from the galaxy, they can regulate the growth of the supermassive black hole itself. Without enough gas to feed on, the black hole's activity may diminish, reducing the intensity of the winds. This delicate balance between star formation, black hole activity, and galactic winds is a key area of research in modern astrophysics. The study of galactic winds in the Pinwheel Galaxy offers a unique opportunity to observe these processes in action. By analyzing the composition, speed, and direction of these winds, scientists can piece together the history of the galaxy and predict its future. These winds are not just a byproduct of cosmic activity. They are active participants in the life cycle of galaxies, shaping their destinies in ways we are only beginning to understand. As we continue our journey through the Pinwheel Galaxy, we'll next turn our attention to the strange distribution of dark energy within its vast expanse, a phenomenon that challenges our understanding of the universe's most mysterious force. Now, let's venture into one of the most enigmatic aspects of the Pinwheel Galaxy, the strange distribution of dark energy within its vast expanse. Dark energy, the mysterious force driving the accelerated expansion of the universe, is not evenly spread throughout the cosmos. In the Pinwheel Galaxy, its distribution is particularly unusual, offering clues about the galaxy's evolution and the larger structure of the universe. Dark energy is thought to permeate all of space, but its effects are not uniform. In the Pinwheel Galaxy, scientists have observed regions where dark energy appears to be more concentrated, creating pockets of accelerated expansion. These areas seem to influence the galaxy's overall growth, causing certain regions to stretch faster than others. This uneven distribution challenges our understanding of how dark energy interacts with galaxies and raises questions about its true nature. One theory suggests that the distribution of dark energy might be linked to the galaxy's dark matter halo. Dark matter, though invisible, exerts a gravitational pull that shapes the galaxy's structure. The interplay between dark matter and dark energy could explain why some regions of the Pinwheel Galaxy are expanding more rapidly than others. This dynamic relationship between the two invisible forces is a key area of research, as it could shed light on how galaxies evolve over billions of years. The strange distribution of dark energy also has implications for the universe as a whole. If dark energy behaves differently in certain galaxies, it could mean that its effects vary across the cosmos. This variability could help explain why some regions of the universe are expanding faster than others, a phenomenon that has puzzled astronomers for decades. By studying the Pinwheel Galaxy, scientists hope to uncover patterns that might reveal the underlying rules governing dark energy's behavior. What makes this phenomenon even more intriguing is its connection to the galaxy's future. As dark energy continues to drive the expansion of the universe, its uneven distribution in the Pinwheel Galaxy could influence how it interacts with neighboring galaxies. Over time, this could alter the galaxy's shape, star formation rates, and even its ultimate fate. Understanding these processes is crucial for predicting how galaxies like the Pinwheel will evolve in an ever-expanding universe. As we unravel the mysteries of dark energy in the Pinwheel Galaxy, we gain not only insights into this particular galaxy, but also a deeper understanding of the forces shaping the cosmos. Next, we'll explore another fascinating phenomenon, the mysterious infrared glow emanating from certain regions of the galaxy, a clue to hidden cosmic activity. Now, let's shift our focus to another captivating mystery within the Pinwheel Galaxy, the mysterious infrared glow that emanates from certain regions of this cosmic wonder. Unlike visible light, infrared radiation reveals hidden details about the galaxy that our eyes cannot see, offering a unique window into its secrets. This unexplained glow has puzzled astronomers for years, as it hints at processes and structures that remain shrouded in mystery. One of the leading explanations for this infrared glow is the presence of vast dust clouds scattered throughout the galaxy. These clouds, composed of tiny particles of carbon and silicate, absorb light from nearby stars and re-emit it as infrared radiation. In some regions of the Pinwheel Galaxy, these dust clouds are so dense that they obscure entire star clusters, making them invisible in optical light but glowing brightly in the infrared spectrum. This phenomenon not only highlights the galaxy's complex structure, but also underscores the role of dust in shaping its appearance. Another possible source of the infrared glow could be hidden star clusters, regions where new stars are forming at an incredible rate. These clusters are often buried deep within dense clouds of gas and dust, making them difficult to observe directly. However, the intense heat generated by young, massive stars within these clusters heats the surrounding dust, causing it to emit infrared light. This glow serves as a telltale sign of star formation happening in the shadows, hidden from our view but revealed through infrared observations. Interestingly, the distribution of this infrared glow is not uniform across the Pinwheel Galaxy. Some regions shine much brighter than others, suggesting variations in the density of dust or the intensity of star formation. These differences provide valuable clues about the galaxy's history and evolution, as they reflect the interplay between gas, dust, and stars over billions of years. By studying these patterns, scientists can piece together a more complete picture of how the Pinwheel Galaxy has grown and changed over time. The mysterious infrared glow also raises questions about the galaxy's future. As new stars continue to form and old ones die, the balance of dust and gas will shift, potentially altering the intensity and distribution of this glow. Understanding these processes is crucial for predicting how the galaxy will evolve, and what role it will play in the larger cosmic landscape. As we explore the enigmatic infrared glow of the Pinwheel Galaxy, we uncover not just the hidden structures within it, but also the dynamic processes that drive its evolution. Next, we'll turn our attention to another intriguing phenomenon, the unusual binary star systems that defy expectations and challenge our understanding of stellar dynamics. Now, let's venture into the fascinating world of binary star systems within the Pinwheel Galaxy, where pairs of stars dance around each other in ways that often defy our expectations. These systems, composed of two stars orbiting a common center of mass, are not just cosmic curiosities, they are windows into the complex dynamics of stellar evolution and gravitational interactions. One of the most intriguing aspects of these binary systems is their peculiar orbits. Unlike the neat, circular paths we might expect, many of these star pairs follow highly elliptical or even chaotic trajectories. This unusual behavior can be caused by a variety of factors, such as the gravitational influence of nearby stars or the remnants of past stellar collisions. In some cases, the stars in these systems are so close together that they exchange material, creating a swirling bridge of gas between them. This process, known as mass transfer, can dramatically alter the star's evolution, leading to explosive events like nova or even the formation of exotic objects like black holes or neutron stars. Another remarkable feature of these binary systems is the diversity of their components. Some pairs consist of stars that are nearly identical in size and temperature, while others are mismatched, with one star being much larger, hotter, or more massive than its companion. These mismatched systems, often referred to as odd couples, provide valuable insights into how stars of different types interact and evolve over time. For example, a massive star paired with a smaller, cooler companion can strip away its outer layers, leaving behind a dense core that may eventually collapse into a neutron star. The formation of binary star systems is itself a topic of great interest. While some pairs are thought to have formed together from the same collapsing cloud of gas and dust, others may have been brought together later in life through gravitational encounters. In the crowded environment of the Pinwheel Galaxy, where stars are packed closely together, such encounters are relatively common. These interactions can lead to the capture of one star by another, creating a new binary system with a unique history and set of characteristics. Studying these unusual binary systems not only helps us understand the mechanics of stellar orbits, but also sheds light on broader questions about the galaxy's structure and evolution. For instance, the presence of certain types of binary systems can indicate regions of intense star formation or past galactic collisions. By mapping the distribution and properties of these systems, astronomers can piece together a more detailed picture of the Pinwheel Galaxy's history and its place in the cosmos. As we unravel the mysteries of these binary star systems, we gain a deeper appreciation for the intricate dance of gravity and matter that shapes the universe. Next, we'll explore another captivating phenomenon, the galactic fountain, where gas is ejected from the galaxy's center only to fall back in a cosmic cycle of creation and renewal. Now, let's turn our attention to one of the most dynamic processes in the Pinwheel Galaxy, the galactic fountain phenomenon. Imagine a cosmic cycle where gas is launched from the galaxy's center, only to rain back down in a spectacular display of creation and renewal. This process is not just a stunning visual, it's a vital mechanism that fuels the galaxy's ongoing evolution. At the heart of this phenomenon lies the supermassive black hole, whose immense gravitational pull and energetic outbursts propel vast amounts of gas outward into the galaxy's halo. This gas, heated to extreme temperatures, is ejected at incredible speeds, creating a fountain-like flow that extends far beyond the galaxy's core. But this isn't a one-way journey. Over time, the gas cools and condenses, eventually falling back toward the galaxy's disk in a process known as galactic rain. This cycle of ejection and return plays a crucial role in recycling material for star formation. As the gas falls back, it brings with it heavy elements forged in the hearts of stars and supernova. These elements, essential for forming new stars and planets, enrich the galaxy's interstellar medium, creating the building blocks for future generations of celestial objects. Without this process, the Pinwheel Galaxy's star-forming regions would eventually run out of the raw materials needed to create new stars. The galactic fountain also helps regulate the galaxy's overall structure and energy balance. By redistributing gas and energy, it prevents the galaxy's core from becoming overly dense or unstable. This balance is critical for maintaining the galaxy's spiral arms and ensuring that star formation occurs at a steady, sustainable rate. In a way, the galactic fountain acts as a cosmic thermostat, fine-tuning the conditions necessary for the galaxy's continued growth and stability. What makes this phenomenon even more fascinating is its connection to other cosmic processes. For instance, the outflowing gas can interact with the galaxy's magnetic fields, creating intricate patterns and structures that astronomers are still working to understand. Additionally, the returning gas can trigger new waves of star formation, leading to the birth of star clusters and even entire stellar nurseries. As we explore the galactic fountain, we gain a deeper appreciation for the interconnectedness of the universe's processes. This cycle of ejection and return is a testament to the delicate balance that governs the cosmos, ensuring that even in the vastness of space, nothing is ever truly lost, it's simply transformed. Next, we'll delve into another intriguing mystery, the strange alignment of planetary nebulae within the Pinwheel Galaxy, and what it reveals about the galaxy's history. Now, let's shift our gaze to another captivating mystery within the Pinwheel Galaxy, the strange alignment of planetary nebulae. These glowing shells of gas and dust, remnants of dying stars, are scattered throughout the galaxy, but what makes them truly remarkable is their peculiar arrangement. Unlike the random distribution seen in many other galaxies, the planetary nebulae in the Pinwheel Galaxy appear to align along specific axes, creating a pattern that has puzzled astronomers for decades. One leading theory suggests that this alignment is tied to the galaxy's magnetic fields. As stars reach the end of their lives and shed their outer layers, the resulting planetary nebulae may be shaped and oriented by the magnetic forces present in the galaxy. These fields could act like invisible hands, guiding the nebulae into a coordinated arrangement. This idea is supported by observations showing that the nebulae often align perpendicular to the galaxy's disk, hinting at a deep connection between their formation and the galaxy's overall structure. Another fascinating possibility is that the alignment reflects the galaxy's history of interactions with other cosmic objects. Over billions of years, the Pinwheel Galaxy may have experienced gravitational tugs from nearby galaxies or even absorbed smaller ones. These interactions could have influenced the orbits of stars and, in turn, the orientation of the planetary nebulae they leave behind. By studying these patterns, astronomers can piece together clues about the galaxy's past, including its encounters with other galaxies and the forces that have shaped its evolution. The alignment of planetary nebulae also offers insights into the life cycles of stars within the Pinwheel Galaxy. These glowing remnants are the final stages of stars similar in size to our Sun, and their distribution provides a snapshot of where and how these stars lived and died. By mapping their positions, scientists can trace the history of star formation and death across the galaxy, revealing how different regions have evolved over time. What makes this phenomenon even more intriguing is its potential to teach us about the broader universe. If planetary nebulae align in specific ways due to magnetic fields or galactic interactions, similar patterns might exist in other galaxies as well. This could open up new avenues for understanding how galaxies form, evolve, and interact on a cosmic scale. As we unravel the mystery of the aligned planetary nebulae, we gain a deeper appreciation for the intricate processes that shape the universe. These glowing remnants are not just beautiful cosmic relics, they are storytellers revealing the history and dynamics of the Pinwheel Galaxy. Next, we'll explore another enigmatic phenomenon, the mysterious fast radio bursts detected from this galaxy and what they might tell us about the cosmos. Now, let's turn our attention to one of the most baffling phenomena in the Pinwheel Galaxy, the mysterious fast radio bursts. These incredibly brief but powerful bursts of radio waves last only milliseconds, yet they release as much energy as the sun does in an entire day. First discovered in the early 2000s, fast radio bursts have since become one of the most intriguing puzzles in modern astronomy. And while they've been detected across the universe, the ones originating from the Pinwheel Galaxy add an extra layer of mystery to this cosmic enigma. So, what exactly are fast radio bursts? Imagine a flash of radio light so intense that it outshines entire galaxies for a fraction of a second. These bursts are so short-lived that capturing them requires precise timing and advanced technology. The ones detected in the Pinwheel Galaxy are particularly puzzling because they don't seem to follow a predictable pattern. Unlike some fast radio bursts that repeat at regular intervals, these appear to be one-off events, making them even harder to study and understand. One of the leading theories about their origin points to highly energetic cosmic events, such as the collision of neutron stars or the explosive deaths of massive stars. When these cataclysmic events occur, they could release a burst of energy that travels across the universe, appearing as a fast radio burst when it reaches us. Another possibility is that they come from magnetized neutron stars with incredibly strong magnetic fields. These stars can produce sudden, intense bursts of energy, which might explain the fleeting nature of fast radio bursts. But why are they so difficult to study? For one, their unpredictability makes them hard to catch in action. Astronomers have to constantly monitor the skies, hoping to catch a glimpse of these milliseconds-long events. Even when they do, the bursts are often so faint by the time they reach Earth that distinguishing them from background noise is a significant challenge. Additionally, the Pinwheel Galaxy's distance over 21 million light-years away means that the signals we detect are incredibly weak, requiring some of the most sensitive radio telescopes in the world to pick them up. Despite these challenges, studying fast radio bursts could unlock new insights into the universe. They act like cosmic probes, traveling through vast stretches of space and interacting with the material they encounter along the way. By analyzing how these bursts are affected by their journey, scientists can learn more about the distribution of matter in the universe, including the elusive cosmic web that connects galaxies. The fast radio bursts from the Pinwheel Galaxy remind us that even in a galaxy filled with strange and wondrous phenomena, there are still mysteries that defy explanation. As we continue to unravel their secrets, we edge closer to understanding not just the Pinwheel Galaxy, but the broader workings of the cosmos itself. Next, we'll explore another intriguing aspect of this galaxy, the unusual distribution of dark matter and what it reveals about the hidden forces shaping the universe. Now, let's shift our focus to one of the most enigmatic aspects of the Pinwheel Galaxy, the unusual distribution of dark matter. Dark matter, the invisible substance that makes up a significant portion of the universe, plays a crucial role in shaping galaxies. Yet, in the Pinwheel Galaxy, its distribution is anything but ordinary. Unlike the smooth, even spread seen in many other galaxies, the dark matter here appears to be clumped in unexpected ways, creating pockets of density that defy conventional models. So, how does this strange distribution affect the galaxy? One of the most noticeable impacts is on the galaxy's rotation. In most galaxies, stars and gas on the outer edges move slower than those closer to the center, following predictable patterns. But in the Pinwheel Galaxy, the rotation curve, the speed at which stars and gas orbit the center doesn't match what scientists expect. Instead of slowing down, the outer regions maintain a surprisingly high speed, suggesting that dark matter is exerting a stronger gravitational pull than anticipated. This anomaly hints at a complex interplay between visible matter and the hidden dark matter framework. What makes this even more fascinating is what it reveals about the nature of dark matter itself. The clump distribution suggests that dark matter might not be as uniform or passive as once thought. Some theories propose that interactions between dark matter particles could cause it to gather in specific areas, creating these dense regions. Others suggest that the Pinwheel Galaxy's history, including past collisions or mergers with smaller galaxies, might have disrupted the dark matter's distribution, leaving behind these unusual patterns. Studying this phenomenon isn't just about understanding the Pinwheel Galaxy, it's about unraveling the mysteries of dark matter on a universal scale. By analyzing how dark matter influences the galaxy's rotation and structure, scientists can refine their models of how galaxies form and evolve. It also provides clues about the properties of dark matter itself, such as its density, behavior, and potential interactions with other forms of matter. The Pinwheel Galaxy's unusual dark matter distribution serves as a cosmic laboratory, offering a unique opportunity to explore one of the universe's greatest mysteries. As we continue to study this phenomenon, we edge closer to answering fundamental questions about the nature of dark matter and its role in shaping the cosmos. Next, we'll delve into the final phenomenon on our list, the evidence suggesting the Pinwheel Galaxy is on a collision course with another galaxy, and what this means for its future. Now, let's turn our attention to the final and perhaps most dramatic phenomenon on our list, the evidence suggesting the Pinwheel Galaxy is on a collision course with another galaxy. Galactic collisions are among the most spectacular events in the universe, and the Pinwheel Galaxy may be no exception. Observations reveal that this galaxy is slowly but surely moving toward a neighboring galaxy, setting the stage for a cosmic encounter that will reshape both over millions of years. So, what does this impending collision mean for the Pinwheel Galaxy? When galaxies collide, it's not a catastrophic crash like you might imagine. Instead, it's a slow, intricate dance governed by gravity. Stars within each galaxy are so far apart that they rarely collide. Instead, the gravitational forces between the two galaxies pull and twist their structures, creating stunning tidal tails, bridges of gas, and bursts of new star formation. For the Pinwheel Galaxy, this collision could lead to a dramatic transformation of its iconic spiral arms, potentially merging them into a new, irregular shape or even forming a larger elliptical galaxy over time. One of the most fascinating aspects of this process is how it triggers star formation. As the galaxies interact, clouds of gas and dust are compressed, igniting the birth of countless new stars. This means the Pinwheel Galaxy could experience a surge in stellar activity, lighting up its already vibrant regions even further. However, this isn't just a visual spectacle, it's a crucial phase in the galaxy's evolution. The collision will redistribute its gas, dust, and stars, fundamentally altering its structure and composition. But what about the long-term effects? Over billions of years, the two galaxies will likely merge into a single, larger galaxy. This new entity will bear little resemblance to the Pinwheel Galaxy we see today, with its spiral arms likely replaced by a more chaotic or elliptical shape. Yet, this process is a natural part of galactic evolution. In fact, our own Milky Way is on a similar path, destined to collide with the Andromeda Galaxy in the distant future. The Pinwheel Galaxy's collision serves as a reminder of the dynamic and ever-changing nature of the universe. It's a process that not only reshapes galaxies but also enriches them with new stars and elements, contributing to the cosmic cycle of creation and transformation. As we conclude our exploration of the Pinwheel Galaxy's strange phenomena, we're left with a profound appreciation for the mysteries and wonders it holds and the countless questions that still await answers. As we wrap up our journey through the Pinwheel Galaxy's most intriguing mysteries, it's clear that this cosmic wonder is a treasure trove of scientific marvels. From the supermassive black hole at its heart to the evidence of an impending galactic collision, Each phenomenon we've explored reveals a piece of the galaxy's complex and dynamic story. The Pinwheel Galaxy stands out not just for its beauty, but for the countless questions it raises about the nature of the universe. Its bright spiral arms, intense starburst regions, and enigmatic dark matter halo are just a few of the features that make it a subject of endless fascination for astronomers and space enthusiasts alike. Yet, despite all we've learned, the Pinwheel Galaxy remains shrouded in mystery. What causes its unusual radio emissions? How do its hypervelocity stars achieve such incredible speeds? And what will its future look like as it collides with another galaxy? These questions remind us that the universe is full of wonders waiting to be uncovered. Each discovery brings us closer to understanding the cosmos, but it also opens the door to new mysteries that challenge our imagination. Now, we'd love to hear from you. Which of these 25 strange phenomena captivated you the most? Was it the mysterious gamma-ray bursts, the peculiar alignment of magnetic fields, or perhaps the evidence of galactic cannibalism? Share your thoughts in the comments below. We're excited to hear your perspectives and spark a conversation about the wonders of space. If you enjoyed this cosmic exploration, don't forget to hit the like button and subscribe to our channel for more deep dives into the mysteries of the universe. From distant galaxies to the secrets of our own solar system, there's always more to discover. Thanks for joining us on this journey through the Pinwheel Galaxy, and we'll see you in the next video as we continue to unravel the mysteries of the cosmos. Until then, keep looking up.